Hey, welcome back. So last time we had talked about pretty much the introduction to polynomials, and I said next time we'd talk about sketching these polynomials a little bit. So I'm going to pretty much take everything we did in the last video and kind of put it to use. Now, before we begin, there's a couple things that I saw that were problematic in the attendance task last time, and one of those was just finding the degree of a problem written in what is known as intercept form. And the way to do this, and maybe I'll be a little bit more specific this time, is to rewrite this problem not with these numbers, but just think about the x's themselves. So think of this problem really as just x times a third x. Forget about all the other numbers now. And then multiply these up. So x times x times x, which is x cubed. So that would be the degree of that polynomial. Okay, so just a quick heads up from last time. You're going to need to know that today as well. Okay, so how do I sketch one of these? So you're going to start by finding out the degree and the leading coefficient for the polynomial. That's step one. Okay, so luckily I already found the degree here. It's 3. So that would be a odd degree. Next, I'm going to look for the leading coefficient. The leading coefficient would be the number out front. Now, in these problems, either it's going to be positive or negative. In this case, there's nothing there, so I'm going to assume that it's positive. Okay, so think back to the chart. If I have an odd function or an odd polynomial degree with a leading coefficient that's positive, that would mean that my left arrow in this equation is going to be pointing down, and the right arrow would be pointing up. Okay, that would be the tail behavior of this graph. Okay, so I'm going to put arrows to represent that. This is where the graph is going to start and end in this frame. Okay, the next thing I'm going to do is I'm going to find the x-intercepts. This is step 2. And the x-intercepts, it's really easy to do. It's already written in factored form. So you're just going to take each of these, set them equal to 0, and then solve for x. So this set equal to 0, solving for x, you're going to get x equals 3. So this is one of my x-intercepts. When I set this equal to 0 and solve for x, I get -1. That's going to be my other guy. And then the last but not least, x plus 4 equal to 0. I'm going to get -4. So 1, 2, 3, 4. And this is going to be my last point. So 3 points associated with these 3 factors. Okay. Now, to do the sketch part, think roller coaster for a second, and I want you to start always from the left arrow and end on the right arrow. So this would be your start point, and this is your end point. And I want you to ask yourself, I can only go through the x-axis here at these 3 points. If I start here, where would probably be the first place I'd go to? Well, I'm not going to skip this one and go to this one. So I'm going to start by drawing from here to here. Now, I know that I'm going to have to go past the x-intercept, and I'm going to go through to the other side. And at this point, I have to decide, well, where do I go with my graph? Well, I can't keep going up forever because I have to come back down to this guy. And I can't go down and go through the x-axis here because there is no x-intercept here. So I'm going to start by thinking again, roller coaster, hill, come back, and then go through this guy. Now, as far as how tall to make your hill, doesn't matter, or how, in this case, low to make a hill, doesn't matter. But what does matter is, are you starting, are you ending in this arrow, and are you going through the points? The next hill, I'm going to go up, and again, I got to go through this point, and then I'm going to end up here. And now, if it doesn't perfectly end up where you had your arrow first time, that's fine, but this would be the general idea of the polynomial, or how to sketch it. Now, next example. Similarly, we're going to start by finding the degree. So in this case, again, eliminate the numbers and just think x's. So we would have here an x, another x, times a third x times a fourth x. So x times x times x times x, that would be x to the fourth power. So that would be our degree for this one. So that would mean that would be a even degree because 4 is the even number. And I'm going to look out front for my leading coefficient. In this case, that would be a negative. So I'm going to think even function with a negative leading coefficient. My tails this time would be, if you refer back to that chart, would be both pointing down. So on the left side, we got an arrow pointing down, and on the right side, we got an arrow pointing down. Second step, we're going to go ahead and find the intercepts. So now going back to the original equation, I'm just going to set each of these equal to 0 and then plot those intercepts. So set this equal to 0, we get -4. So 1, 2, 3, 4, first intercept. X plus 1 set equal to 0 would be -1 when I solve for x. That would be X-intercept number 2. X equal to 0, well, there's nothing much to do other than x is equal to 0. So anytime you see a lone x like this, that is just going to be a intercept of 0. And then last but not least, x minus 3. So that's going to end up giving us a positive 3 intercept. So this function has 4 x-intercepts, okay? So like last time, I want you to start on the left arrow and then go to the right arrow. This would be the end. And same as last time, try to think, where should I go next kind of thing. So if I start here, where should I go next? This dot, right? So I'm going to go here, I'm going to go through this, right? I got to go back down to this dot, so I'm going to go to this dot. I don't want to go through any other x-intercept point except this point, so I'm going to go through this point. I'm going to quickly, because I got to get up to this point, think again roller coaster, so I have to come back up, go through this guy. And then I know I have to go back here, so I'm going to bend down, go through here, and then go to my arrow, and I am done. So this looks something like the letter M. Again, don't worry about how far down this graph goes. Like if you were to graph this on a calculator, it might not end up looking like this again. The idea is just getting used to, hey, this guy is above the x-axis, this guy is below, this guy is above, that kind of thing, okay? Now on the topic, one last thing, you're going to have a worksheet today, and they're going to talk a little bit about this concept of what is called orientation. Orientation, there are 2 types of orientations, either positive or negative. So let me give you an example. If you're dealing with an odd equation like we did before, or an odd polynomial, if you start low and then end high, they call this a positive orientation. If you are dealing with an even, you start low and then end low, they call this a negative orientation when it's even. Pretty much the right tail, whichever way it's pointing, either odd or even. If it's pointing up on the right side, refer to that as a positive orientation. If it's pointing down on the right side, whether it's even or odd, we call that a negative orientation, okay? Let's sketch a few more real quick. So the next one, start by, again, getting the degree. So x, in this case, it's going to be x, but squared. So we're going to keep those intact, just these numbers, don't think of them. And then x. So if I were to multiply this out, it would be x times x times x times x. So how many x's total? It'd be 4. So in this case, that would be x to the 4th. So the degree this time, again, is 4. But this time, the leading coefficient is, there's nothing there, so we're going to assume it's positive. So we have an even function, or an even polynomial, with a positive leading coefficient. So both arrows are going to be up this time if you refer back to the chart from last time. And let's get our intercepts. So x plus 3 is going to give us a -3 intercept. X minus 2 is going to give us a 2 intercept, and x minus 6 is going to give us 1, 2, 3, 4, 5, 6, a 6 intercept. Now, quick thing. Some problems, and this square does mean something. When the x-intercepts don't have anything next to them, they're just plain old parentheses, you're just going to, like in the other problems we did, just go straight through the x-axis at those intercepts, right? Nothing fancy. Now, something does fancy happen when you have a square here. And this is what you're going to do. When you have a square outside the parenthesis, you are going to not go through the x-intercept, you are going to bounce off the x-intercept, okay? And I'll show you what this does in this. And we're going to practice this a little bit. This takes some time to get used to. But I'm going to start by going through this intercept. So I'm going to start here. I'm going to end here. And I'm going to go first to this guy. I'm going to go through this x-intercept because, again, no squares here, just a normal parenthesis. Now, when I get to this guy, the behavior of this is, instead of going through to the other side, I'm actually, when I get to this x-intercept, I'm going to bounce off it, okay? So think it's like kind of like a roller coaster. It's a hill, but the hill actually ends at this spot. So it deflects it back down, okay? So you can't go through the x-axis. When there's a squared, you bounce off of it, okay? Now, I'm gonna have to come back to this x-intercept. This time I go through because it's just a plain old x-intercept, and luckily when I go through, there's an arrow to go to, so that's the next step, all right? So squares, think bounce, okay? You bounce off, and you can bounce off from the bottom or the top depending on which or where you're coming from. All right, last but not least, lots of stuff going on here, so let me start by getting the degree. So we got x, get rid of this part. Anything attached to the x you do want to keep though, so x squared, same with this one, x squared, and this one, x, and then that. So exponents you do keep, it's just the numbers you don't want to think about, okay? All right, so multiplying this out, I got an x times an x squared, that's 3x's so far, times another x squared, that's 5x's so far, and then times another x squared, that's 7x's so far. So this would technically be my degree, is a degree of 7. So that's an odd degree. The leading coefficient is negative. So it's an odd polynomial with a leading coefficient of a negative. So that means my left arrow is up and my right arrow is down. So this would be a negative orientation for those of you guys keeping track. Let's go ahead and get the x-intercepts next. So we're going to start with this lone x. That's going to be an x-intercept to 0 because we're going to set it equal to 0. So there you go. Now, this one's going to take a little bit extra work. So I'm actually going to do this by hand. X squared plus 3 equals 0. Solve for this x. So I'm going to get x squared, subtract 3, negative 3. I'm going to square root both sides and plus minus the square root of negative 3. Now, if you throw in square root of negative 3 in your calculator, you're going to notice that it's going to give you an error. That's because you can't square root a negative number. Therefore, this technically doesn't have real solutions. So this guy right here, there is no x-intercepts for him. There's actually going to be, this is no x-intercepts here, okay? There are intercept things going on, but not actually going to show up on the x-intercepts. We'll talk more about that later. So don't worry about him in terms of x-intercepts. Now this guy is set equal to 0. X squared minus 4 equals 0. I am going to get some intercepts. So square root both sides. I'm going to get x equals plus or minus square root of 4, which in this case would be 2. So technically, this guy is actually going to give me 2 x-intercepts, 2 and negative 2. So far, my intercepts are 0, 2, and negative 2. So negative 2 and 2. And last but not least, I got this guy. When I set this parenthesis equal to 0, I get 6. So 1, 2, 3, 4, 5, 6. Now, the difference between a problem like this and a problem like this gave me 2 intercepts, and these are just normal intercepts. I'm just going to go straight through it, no bouncing here. It's when the square is on the outside of the parenthesis when you do the bouncing, okay? I know that's a little confusing, but again, we'll be practicing this for a little bit. So, starting up here on this left arrow, I'm going to go to this intercept. This intercept, again, came from this, so no bouncing here. So I'm just going to go here. I'm going to go through this guy. I'm going to go up. I'm going to go through him. He has no square on the outside of him, so I'm just going to go through him. I'm going to go next to this 2. This came from this guy, so no squares on the outside, so I'm just going to go through him. And then I'm going to go through this guy, but you'll notice that, again, he came from a square on the outside, so I am going to bounce off this guy and go back down. And the reason why this also makes sense is if I were to go through him and then go up to this other side, in order to get down to this arrow, I would have to come back down one more time. And when I do that, I would create another x-intercept, which again, I don't have because it would have to show up here. So again, that's another clue that I'm going to have to bounce down to get down to that arrow. Okay. So that is a few examples of sketching polynomials. Now, one last thing I do want to talk about is you can do the reverse of this. So like if you know how to sketch polynomials, you should be actually able to find equations of polynomials as well. So I'm going to do a quick example of this as well before we wrap up. So before, let's start by like looking at these x-intercepts. So our x-intercepts are going to be at 1, 2, 3, 4, negative 4, at positive 1, and at positive 1, 2, 3. Okay, I can write this as an intercept form. Because that's what we've been doing. Just think opposites here. So this, instead of being x minus 4, this actually would be x plus 4, right? Because setting this equal to 0 would get me the negative 4. I'm going to do x minus 1 to get me a positive 1. But I notice there's a bounce at that one, so I'm going to put a squared on this guy. And then last but not least, this one goes through that, so x minus 3. So this would be the equation of this. Now, if I want to find the exact equation, meaning like if I were to actually throw this into a calculator and get this exact thing, I would need one extra point, and you'll notice that they gave me a point here to use. Now, to do this problem, what you're going to do is you're going to, like we've done before in this class, you're going to think of this leading coefficient here, because that leading coefficient is what's going to ultimately get everything to snap into place. You're going to have to solve for it. And to get that value, you're going to have to plug the point they give you in for x and y. So in this case, I'm going to plug in negative 2 for y, and then 0 for all my x's, and then solve for a. So I'm going to do that real quick, and that would be how I could get an exact equation for these problems. So negative 2 equals a times, in this case, 4, negative 1 squared, which would be 1, and then times negative 3. So negative 2 equals a, 4 times 1 times negative 3 would be negative 12. And then to get a by itself, I would divide by negative 12, whoopsies, on both sides. So negative 2 divided by negative 12 would be a positive, if I were to reduce it, 1/6, or I can think of that as a decimal answer. And then if I want to find the exact equation, I could rewrite that equation, but this time with that leading coefficient, and then we'd all be good. So 1/6, x plus 4, x minus 1 squared, x minus 3. Okay, so the worksheet today is going to have you go through these. There are some worked out examples in this packet, so you can at least look through those, as well as the examples I did in the video, and hopefully that's enough to get the ball rolling. I know you're not going to be perfect at these at first, but with more practice that we're going to continue doing, hopefully you'll get these by sometime next week. Okay, you guys have a wonderful day. See you next time.